Dear students, good morning to all. Hello?
Sir.
Do you receive my voice?
Yes, sir.
Okay. Very good morning to all. Okay, our today's topic is nickel prism, polarization by scattering. You know well the polarization techniques. Polarization techniques. How many techniques have in our textbook? Anybody?
Sir, 4.
Okay. What are the 4 techniques? Hello?
Yes, sir.
Say anyone.
Polarization by selective absorption,
Very good.
polarization by reflection, polarization by double refraction, and polarization by scattering.
Very good. 4 techniques you have in the textbook. First one is a polarization by selective absorption. You detailed explained based of Moore's law. Am I right? And second one is polarization by reflection. You clearly explained this is Brewster's law. Mu is equal to tan IP. I mean the refractive index of medium is equal to tangential of polarization angle. And next one is polarization by double refraction. You know well double refraction. Am I right? And next topic is a very important polarization by scattering. Polarization by scattering, last technique in polarization. And before polarization by scattering, the nickel prism is a very important role in this book. Because of nickel prism is a very important in this optics. It's a very what did say? Most of applications are available based off polarization. First of all, nickel prism. What is nickel prism? So very important. Nickel prism. What is nickel prism? The nickel prism is an optical device which changes unpolarized light to polarizing light. The nickel prism is an optical device which changes unpolarized to polarized light, which means unpolarized or ordinary light into plane polarized light or completely polarized light. Plane polarized light is nothing but a completely polarized light in particular direction. By double refraction, the main principle of nickel prism. What is the principle of nickel prism? Double refraction. Principle of nickel prism is double refraction. What do you mean by double refraction? Say anyone? Say anyone? What do you mean by double refraction? Hello?
Sir, when a ray of unpolarized light is incident on calcite crystal, 2 refracted rays are produced.
Which means unpolarized light incident on the calcite crystals. These calcite crystals produces 2 images. 2 images based on the 2 rays are required. One is ordinary ray, another one is extraordinary ray. One is ordinary ray, another one is extraordinary. For example, if a calcite crystal means when light incident, this is unpolarized light. What do you mean by unpolarized light? Unpolarized light means the vibration should occur in all directions. This unpolarized light incidents on the calcite crystals, it is produced 2 images. 2 images. One is the ordinary ray, another one is extraordinary. Extraordinary ray. Another one is ordinary ray. Which means the images, two images are like two images of single object on basis of double refraction. Basis of double refraction. One is extraordinary ray, another one is ordinary ray. It is a very important role. These ordinary ray obey the laws of reflections and the refractions. But extraordinary rays not obey laws of reflection and the refraction. Okay. Hello.
Yes, sir.
Very good. A Nickel prism is an optical device to change a sun-polarized or ordinary light into plane polarized light by the principle of double refraction. By the principle of double refraction. This is a very important one. Say, Nickel prism. What is Nickel prism structure? Nickel prism consists of two calcite crystals coupled together. Material called Canada balsam. This is another one important one. Canada balsam. This is a liquid cement. Liquid cement. The nickel prism consists of two calcite crystals together with a material called Canada. When unpolarized light is passed through the nickel prism, it splits into ordinary ray and the extraordinary ray by double refraction. By double refraction. The construction of nickel prism is based on the phenomenon of double refraction. Based on the phenomenon of double refraction. It is a very important. This is the principle of nickel prism. Double refraction. Double refraction. And another one is a very important. Its length is 3 times breadth. Its length is 3 times its breadth. It has 6 phases of parallelogram. Most of them, this is 6 phases of parallelogram. The structure of calcite crystal. This is a very important. The structure of calcite crystal is almost divided, partially divided through diagonal. It is a important role because of this is to produce the two rays. When unpolarized light incidents on this phase, these produces extraordinary ray and ordinary ray. Extraordinary ray, most of them plane polarized in particular direction, and ordinary ray also produces plane polarized light. Plane polarized light. What is polarized light? What is unpolarized light? The vibrations of plane polarized light. I particularly want to calculate the direction and the vibrations also. Listen to me. When unpolarized light, symbol of unpolarized light is this. This is unpolarized light symbol. This is the unpolarized light means the vibrations of particles are available in all directions. Just we are simply make this. This is unpolarized light. This is, which means light is also electromagnetic wave. That's why we are considering only two factors: electric and magnetic field. I mean, this is vibration. This vibration is parallel. These vibration dot production is perpendicular. I mean, the perpendicular to the propagation of light. I mean, the dot indicates this perpendicular light to the propagation. Another one, this is parallel to the plane. It is a very important. This dot indicates the perpendicular to the plane. This is unpolarized light. Unpolarized light. When these unpolarized light incident on particular crystals or metal, this is plane polarized after refractor ray. The symbol of after refractor ray. This vibration is only This is plane polarized light having vibration in plane of the paper. The vibration is plane of the paper. Listen. The polarizer or analyzer. These vibration, these plane of the paper, I mean this plane is allowed to the parallel vibrations. Plane polarized light having vibration in the plane of paper. This light is called symbol of plane polarized. Plane polarized. Plane polarized light. This is plane polarized light having vibration in plane of the paper. Vibrations in plane of the paper. Vibration is plane of the paper. And another one vibration is required. This dot indicate perpendicular. This dot is perpendicular. This plane, consider this is one plane. I mean, it's a polaroid or analyzer. These vibrations is perpendicular to the plane of the paper, which means this dot indicate the perpendicular to the plane of the paper. This is in this vibration. This vibration is perpendicular to the plane of the paper. This is symbol of unpolarized light. This is plane polarized light along the directions of propagation of light, which means this vibration is parallel to the plane of the paper. This vibration is perpendicular to the plane of the paper. Perpendicular to the plane of the paper. This is a polarized light, unpolarized light symbol. So what do you mean by nickel prism? Nickel prism unpolarized light to polarized light. It was invented by William Nickel. 1828. Invented by William Nickel, 1828. The nickel prism consists of two calcite crystals cemented together. The cemented name is called as a calcium. It is a very important liquid cement. When unpolarized light is passing through the nickel prism, it is split into two rays based on double refraction. One is ordinary ray, another one is extraordinary ray. One is what are the two rays?
Ordinary rays, extraordinary rays.
Extraordinary rays.
One is ordinary ray, which means O ray. Another one is extraordinary ray. Am I right?
Yes, sir.
When unpolarized light incidents on the crystal, ordinary ray, which is electrical vector perpendicular to the principal section of the crystal. Electric vector perpendicular to the crystal section. Extraordinary, which is electric vector parallel to the principal section of the crystal. Am I right? Which means this is ray, this is. Says or no? These rays plane polarized light, extraordinary ray, is parallel to the these vibrations of electric vector vibration is parallel to the principal section of the crystal. Am I right? Says or no?
Yes, sir.
This is parallel to the principal section of the crystal. This is principal section of the crystal, parallel to the principal section of the crystal. Ordinary ray.
Perpendicular.
Very good. Ordinary ray, which is equal to, this is dot indicate. This is dot. This is dot. Perpendicular. This vibrate. This crystal. This is perpendicular. Am I right? Perpendicular to the principal section of the crystal. This is a principal section.
Yes, sir.
Crystals. Am I right?
Yes, sir.
Very good. Now we are discussing about topic is nickel prism. The nickel prism is there's a nickel prism. It's a very important one. Consider nickel prism. Nickel prism is nothing but is unpolarized light converted to polarizing light. I mean, based on double refraction, you consider the crystal This crystal initially the crystal angle is almost equal to this is 72 degree, this is 108 degree. 72, this is 108 degree. 72, 108 degree. This crystal is the real phase is this. The real phase of crystal. This is divided. I mean, this is a real phase of crystal. This is just see this. It has a almost six parallelograms. This one is a one parallelogram, and this is another one parallelogram, and this is, and this is, and another also this phase also. These almost crystals, calcite crystals. These crystals make an angle of initially 72 degree. I mean, this angle is 72 degree. This is 72 degree. This is 108. Is divided. I mean, this is a divided in two parts, almost through diagonal. The phase should be changed. Initially, the crystal phase. This is 72, this is 108. Not 8. Now here almost divided in two parts of passing through the diagonal. Then the angle should be changed. Angle should be changed. This is A, B, C, D. Before phase, the angle is 72 and 108 degree. And next one is after this is divided in two parts, and using the Canada prism should maintain this. One of the most common form of canonical prism is made by making calcite crystals. Double refraction. The length of these is 3 times of its breadth. 3 times of its breadth. And here we see the represents the principal section of calcite crystals. Just is cut into two half of along diagonal. Divided into half along the diagonal. That the phase angles are 72 degree and 180 degree. The two are joined together by using the Canada branch. By using the Canada branch. This liquid layer is called as a Canada branch. Suppose this is a liquid cement, simply called as a liquid cement. This is Canada branch. Now the degree should be changed, which means this is A, this is B, this is C, this is D. After divided this, the angle should be changed. The angle should be changes. Listen to me. This is now this is A, now this is A dash. This is D dash, this point is D. So now the angle after the two these crystals, the angle should be changed. Now this is 72. First of all, now after this value, two half of the diagonals along the diagonal, now angle should be changes. Now this angle is this is 6 and this is almost 90 degree. So what is this? This is 68 degree. This is almost 90 degree means what is the angle this? Anyone? Hello? Hello?
Sir.
What is this? What is the angle? This is 60-80 degree. This is 90 degree. What is this?
22 degree.
Very good. This is 22 degree. And overall this is also 22 degree, and this is almost 90 degree. This is 68 degree. 68 degree. This is a basic information of nickel prism. Basic information of nickel prism. I give you one diagram. See this. After cut the diagonals, after cut the calcite crystals, the angle should be changes. This is 68 degree, this is 90 degree, this is 28 degree, and this angle is also 28 degree. This is 28 degree. The angle should be 72 to 68 degree. The angle should be converted. Another one is a very important role. The refractive index of Canada Pacific is 1.55. This is a very another one important point. Refractive index of Canada Pacific is equal to 1.55. Please take your textbook and note the points. Refractive index of Canada Pacific is 1.55. And refractive index of ordinary ray, which means unpolarized light incident on the surface of this is A, B, C, D. See the surface of AB, unpolarized light incidents on the surfaces of AB. These unpolarized light is divided two rays. Am I right? Am I right? One is ordinary ray, another one is extraordinary ray. Ordinary ray obey the laws of reflections and the laws of refraction, but extraordinary rays not obey. So unpolarized light, this is vibration, this vibration, and dot is also another perpendicular vibration to the plane. And listen to me, the incidence on the surface of AB, unpolarized light is divided two parts. One is basis of double refraction, one is extraordinary ray, another one is ordinary ray. These extraordinary ray passing through the Canada pulsar, the vibration, listen to me, this vibration, the vibration name is this. Extraordinary ray, this is parallel to the principal section of the crystal. Parallel to the principal section of the crystal. This is extraordinary. And another one is perpendicular to the principal section of the crystal is ordinary. This is allowed only one vibrations along the directions of parallel to the plane of the paper or plane of the vibrations. This is parallel to the plane of the paper. This vibration is perpendicular to the plane of the paper. Perpendicular to the plane of the paper. This perpendicular to the plane of paper image produces, this ray is called as a ordinary ray. And the parallel to the plane of the vibrations is nothing but this is extraordinary. When the unpolarized light incidents on the Canada pulsar, this is divided in two rays. One is extraordinary ray, another one is ordinary ray. So listen to me, this is very important. Extraordinary ray vibration is parallel to the plane of the paper. Ordinary ray is perpendicular to the plane of the paper. But the ordinary ray reaches the Canada pulsar. What happened? To draw the normal. This is angle of incidence of the ordinary. And also unpolarized light incidence on the faces of AB. This also produces an angle of incidence. Am I right? So listen to me, it's very important. This is angle of incidence of unpolarized light. In crystal, this is angle of incidence of ordinary ray. And incidence on the Canada pulsar. The ordinary ray obeyed the law of reflection and refraction. That's why the ordinary ray should be deviated. The refractor. And the extraordinary is not obeyed. That's why it will pass through the crystals. But here, very important role. Refractive index of Canada pulsar is 1.55. Refractive index of ordinary ray is equal to 1.658. refractive index of extraordinary ray, which is equal to 1.486. 1.486. It is a very important point. Just observe it. So the unpolarized light incidence on the face of AB is divided into two rays. One is extraordinary, another one is ordinary. When the ordinary ray refractive index is 1.658, am I right? The refractive index of Canada Palsum is 1.55. Which one is rarer? Which one is denser? Hello? Will you receive my voice?
Yes, sir.
The refractive index of Canada Palsum is 1.55. An ordinary ray is 1.658. And the extraordinary refractive index is 1.486. Okay. Hello?
Yes, sir.
Very good. So the Canada Palsum act as rarer medium for
Ordinary ray.
no.
Ordinary ray.
Refractive index of Canada Palsum is 1.55. Ordinary ray refractive index is 1.658. So compare these two.
Extraordinary ray.
Compare this Canada Palsum and ordinary ray. So the Canada Palsum act as rarer medium. Am I right?
Rarer medium. Yes, sir.
Rarer medium for
Ordinary ray.
ordinary ray. Because of the ordinary ray refractive index is 1.6. Am I right?
Yes, sir.
Very good. Refractive index of Canada Palsum is
1.5.
1.55.
523.
So the Canada Palsum act as rarer medium for
Ordinary ray.
ordinary. Compare these two, Canada Palsum and the extraordinary ray. Refractive index of Canada Palsum, which is equal to 1.55. Refractive index of extraordinary ray, which is equal to 1.486. Am I right? The Canada
Yes,
Palsum
sir.
of refractive index is 1.5. This is 1.486. Which one is greater?
Canada Palsum.
So the Canada Palsum act as
Denser medium.
denser medium for
Extraordinary ray.
very good extraordinary. Am I right?
Yes, sir.
So the extraordinary ray passes to ordinary ray, just act as Canada Palsum act as Canada Palsum act as rarer medium for ordinary ray. Am I right?
Yes, sir.
Very good. So the ordinary ray will pass through the denser to rarer.
Yes, sir.
Very good. Extraordinary ray.
Rarer to denser.
Very good. The Canada Palsum act as rarer medium for ordinary ray. It's a denser medium for extraordinary ray. So the ordinary ray passes from portion of crystal into layer. Layer means Canada Palsum. It passes from denser to rarer medium. Am I right?
Yes, sir.
Very good. Are the extraordinary rays rarer to denser?
Yes, sir.
Rarer to denser. This is denser to rarer. So ordinary ray is passes from denser to rarer. Extraordinary passes from rarer to denser to rarer. Ordinary ray denser to rarer. Extraordinary rarer to denser. When angle of incidence is greater than the critical angle, it is very, very important. You know the total internal reflection. What do you mean by total internal reflection? TIR, total internal reflection.
greater than critical angle, it
Very good.
traces its path.
Very good. The angle of incidence when the light travel from denser to rarer medium. Denser to rarer medium. This is the angle of incidence. Angle of incidence. Denser to rarer. After refraction, bend away from normal. Am I right? When
Yes,
reaching particular angle of incidence, there is no refraction. I mean, the refracted ray almost will merge on the surfaces. This is greater than critical angle. Greater than the critical angle. I mean, the angle of incidence is greater than the angle of critical incidence. The refraction is not possible. The totally internal reflector means the ray should be totally internal reflector, which means this is a very, very important one. The ordinary ray obtains totally internal reflection. Totally internal reflections. Total internal reflections. Because of the ray must be, I mean, the Canada parasum act as rare medium for ordinary ray. So the ordinary ray just passes from denser to rarer. That's why the ordinary ray must be affected by total internal reflection. Total internal reflection. I mean, this is I non-value rays. See this value, this angle of incidence. This value is 60-80 degree. Am I right? I mean, this
Yes,
angle
sir.
of incidence attain above 68 degree. The ordinary ray must be affected by total internal reflections. Total internal reflections. I want to calculate this angle of incidence. You know well the refractive index of second medium with respect to first medium, basis of Canada parasum. I want to calculate the refractive index of medium, which is mu is equal to mu of Canada parasum divided by mu of ordinary divided by ordinary ray divided by mu of Canada parasum. What is the ordinary ray value? What is the ordinary ray refractive index of ordinary ray?
1.658.
Divided by ordinary of refractive index of Canada parasum 1.55. Mu is equal to. Am I right?
Yes, sir.
According to Brewster's law, you know well, polarization by reflection. Sin C is equal to. Sin C is equal to 1 by mu. Am I right?
Yes, sir.
Sin C is equal to 1 divided by mu. So sin C is equal to 1 divided by mu value is 1 mu value is equal to 1.658 divided by 1.55. 1 by mu is equal to
1.55 by 1.65.
very good. 1.55 divided by 1.658. Sin C is equal to. So who is C? Who is C? This is critical angle. So sin C, which is equal to almost 9348, the value C is equal to sin inverse 9348. Finally, you get C is equal to this value is equal to almost 69 degree. 69 degree. So C value is equal to 69 degree. See the diagram. Here, this is attained to the angle of is 68 degree. 68 degree. This is attained. This is 69 degree. This value, angle of incidence of ordinary ray attained 69 degree. 69 degree, which means greater than the critical angle. That's why it's affected by total internal reflection by the Canada parasum. By the Canada parasum. That's why this vibration is passing through this direction. This vibration is perpendicular to the plane of the paper. The perpendicular to the plane of the paper. I mean, these vibrations are called as an ordinary ray. These ordinary ray affected by total internal reflection because of the incidence value is greater than the angle of incidence 68. I mean, this is attained the 69 degree. So reach in total internal reflection. Reach in total internal reflection. This is greater than the critical angle. So ordinary ray affected by total internal reflection. Any doubt?
No, sir.
Just take notes, it's very, very important. When angle of incident is greater than the critical angle, the ordinary ray is totally reflected. It's not transmitted. It is an important condition and a key point also. Just take notes. When the angle of incidence is greater than the critical angle, I under 90 degree for angle of incidence of ordinary ray is equal to attain 69 degree. Because of Canada Passion refractive index is 1.55, ordinary ray is 1.658. So this is Canada Passion act as a rarer medium for ordinary ray. So ordinary ray must be traveled from denser to rarer.
Ordinary ray.
Denser to rarer. So these values, I want to calculate the critical angle. Critical angle is equal to attain 69.
1 by mu.
69 degree. I mean the formula is equal to sin c is equal to 1 divided by mu. Mu is equal to 1 divided by sin c. So mu value is 100 equal to almost final value. Critical angle is equal to 69 degree. Basis of Brewster's law. Just you consider this. Sin c is equal to 1 divided by mu. Mu is equal to tan ip. Am I right?
Yes, sir.
Basis of Crystal's law. I mean the Brewster's law. I mean
Brewster's
mu is equal to tan ip. Mu is equal to
tan I.
tan ip. Ip is a polarizing angle. Mu is the refractive index of the beam. I mean c is the critical angle. Sin c is equal to 1 divided by mu. So the sin c value is attained is equal to 69 degree. Basis of these values: refractive index of Canada Passion, refractive index of ordinary ray, and the refractive index of extraordinary ray. What is the refractive index of Canada Passion?
1.5.
55. What is the refractive index of ordinary ray?
1.65.
1.658. What is the refractive index of extraordinary ray?
1.4.
1.486. Am I right?
Yes, sir.
Nickel prism. This is very important role in these three values. By just compare that one by one. Canada Passion and ordinary ray. So the Canada Passion is act as rarer medium for ordinary ray. Okay. Hello.
Yes.
Very good. The Canada Passion is act as denser medium
Yes,
for
sir.
extraordinary. Very good. This is a very, very important. So just in these values, just we measure the critical angle.
Extraordinary ray.
Attain these values equal to 69 degree. That's why ordinary ray just totally internal reflector. So the ordinary ray must be these vibration. Ordinary ray is nothing but the vibrations of light. I mean the perpendicular vibration is perpendicular vibration of plane of the paper. I mean crystal axis is deflected by Canada Passion. Totally internal deflected by Canada Passion. This is very, very, very important role in nickel prism. Nickel prism. And next one is very important. Scattering. Next one is polarization by scattering. Polarization by scattering. What do you mean by scattering? Boys, anybody? What do you mean by scattering? Anybody know Rayleigh scattering law? Hello? Hello? Okay, scattering. Most of them, scattering is mainly depends upon the wavelength of incident light. Scattering is mainly depends on wavelength of incident light, which means the scattering is inversely proportional to 4 to the power of wavelength. If the wavelength is maximum means scattering is minimum. If wavelength minimum means scattering is minimum. Am I right? A very important condition for scattering is the size of scattered particle. Scattered means smallest particle are scattered by the light. Size of scatter should be comparable to wavelength of light. The size of scatter, is should be comparable. Should be comparable to wavelength of light. I mean the scattering is mainly depends on wavelength of light. This is a very important condition of scattering. Condition of scattering. Size of scatter should be comparable to wavelength of
Light.
incident light. So polarization by scattering means is a very important the condition. Light is also polarized due to the scattering of light by small particles. A good example is air molecules. You know, where the sunlight incidents on the Earth atmosphere, the light should be sunlight almost is on polychromatic, including all colors. Incident on the atmosphere of Earth atmosphere, this is scattered by the air molecules. Scattered by air molecules. Am I right? That's why the scattered by the air molecules. That's why sky appears blue. It is a very, very important one. The shorter wavelength are scattered more because of scattering is inversely proportional to 4th power of wavelength. You know well the which you are. Am I right? Say or no?
Yes, sir.
Which color has maximum wavelength?
Red.
Wavelength is
Red.
maximum for red. Am I right? Wavelength minimum.
Violet.
Violet. So which color has maximum scattered?
Violet.
The scattering is inversely proportional to wavelength. Okay.
Violet.
You know well, red is a wavelength is maximum. So the scattering is
Minimum.
Yes, sir.
minimum. Very good. Violet is a wavelength is minimum. Am I right?
Yes, sir.
So scattering
Maximum.
in which are violet and indigo almost
Minimum.
very for human eye. Not to identify this which are. I mean the violet and the indigo color. Listen, is a very important. Violet and indigo is not to identify in human being because of human being high. Because of these two colors are very, very sensitive. So that's why we are only applying blue. The wavelength, compare the red and the blue. Wavelength is minimum for blue. Am I right? Maximum for red. So which color has maximum scattered? Hello? Anybody? Scattering is inversely proportional to wavelength. So wavelength is maximum for red, though. So the scattering is minimum. Wavelength is minimum for blue color. So scattering is maximum. Because of this is blue. Consider this is a blue waveform. This is red waveform. The scattered particle. What is the condition of scattering? The size of scatter should be comparable to wavelength of light. Am I right? If the scattered particle means it's very small, this scattered particle means this is. The blue color must be scattered the particle. Incidence on the scattered particle must be scattered in all directions. The vibration should be available in all directions. But the red color is just if it pass through the scatter. It's not possible to incidence on the particle because of the wavelength of the particle. I mean the wavelength of light is much more. Compare the size of the scattered particle. So the red light is not possible to scatter. For example, you know well the scattering light, reflections, scattering by, polarization by reflections. You know well, if light incident reflector, just consider this incident reflector, incident reflector, incident reflector. This is regular reflections. What happened in spherical shape? Light incident reflector, light incident reflector, light incident reflector, incident reflector, incident reflector. Am I right? This is incident reflector. In spherical shape, this is called as a scattering. In atmosphere, Earth atmosphere, it has a dust particle, water molecule, air molecule. Most of these particles are reflected by sunlight. That's why the sky appears blue color. Sky appears blue color. This is a very, very, very important applications in our day-to-day life. For example, this is incident. This is white light. This is white light. Just we see in this point. See. We see the white light, scattered by the blue color. Most of them scattered. Most of them scattered by blue. Blue color is scattered by more compared than red light. Because of red wavelength is maximum. Scattering condition is the size of the scatter should be comparable to the wavelength of the light. So the blue color must be scattered in sky. In atmosphere of Earth atmosphere. That's why sky appears to blue. But the sunset and sunrises, the maximum blue color should be scattered. The red is not scattered. That's why the wave of red color reach in our eyes. The sunset and sunrise appears to reddish, morning and evening time. That's why it's a very important. So, what is the polarization by scattering? What is the application of polarization by scattering? See. When unpolarized light, listen to me, this is unpolarized light. Unpolarized light, this is one parallel vibration, another one is a perpendicular vibration. The incidence on the molecules of air and water are dust particle M. Incidence on this. This is scattered. If there is no any scattered, just passing through straight line. This is also unpolarized light. It's also unpolarized light. The unpolarized light passing through the molecules. If there is no any transmitted light these are called as transmitted light. There is no any unpolarized light. When the incident to make a particular angle, partially polarized. This is also partially polarized. Partially polarized, half of the ray should be polarized. And reach in particularly 90 degree. This is a very, very, very important condition. Reach in particularly 90 degree. The unpolarized light must be plane polarized. This is plane polarized. Convert to plane polarized. This is plane polarized. This is plane polarized. And perpendicular direction. We mean observer is placed in perpendicular direction. Observer is placed in perpendicular direction. See this. This is observer. The perpendicular direction, the molecules are reaching 90 degree perpendicular direction. The molecules reflected, the transmitter, the energy, unpolarized light convert to plane polarization. Unpolarized is convert to plane polarization. And it's a very, very important. This is x-axis, this is y-axis, this is the axis. When unpolarized light passing through this direction, when reaching the molecule, scattered particle, this is plane polarized light in x-axis. This is z-axis. This is y-axis. In region perpendicular degree, this is plane polarized. And region perpendicular degree, this is plane polarized. This is scattering by polarization by scattering. That's why, for example, sunlight, incident in water molecules, incident overall sunlight, incident water molecules, violet to red. This is only blue color should be reflected, reaching 90 degrees. This is polarized light. These are unpolarized light. This is incident light. This is polarized light, plain polarized light. Only blue color should be reflected. That's why sky appears blue. Sky appears blue. Okay, thank you. Thank you to all. We will meet next class.